So we're looking at factoring here. So for number 36, we're looking for numbers that multiply to 40 and add to 13. If it helps, which I think it does for a lot of people, make a list of factors, a list of ways to multiply to 40. There's not that many ways, and that lowers the number of combinations to think about. And because it's a positive 40 that we're trying to multiply to it, either both factors are positive or both factors are negative. Because we're trying to add to a positive 13, they both got to be positive, so 5 and 8. So x plus 5 times x plus 8. And if you were to multiply this back together, so that's our answer, we're done. Because if you were to multiply this back together, you would end up with the original polynomial. So it is correct, and this is factored form. We can't factor it further. Number 37 is a little bit more challenging. Notice we have an a value there other than 1, so we need to multiply that a value with our c value. So we're looking for ways to multiply to negative 72. That's 6 times negative 12. And then add to our b value, which our coefficient of b there is 1. And so here you get 9 and negative 8. So just like on the other example, we're going to throw those values behind the variable x, because we're dealing with x's in this problem, in factored form. However, because our leading coefficient is not 1, we're going to divide all of these values by what that coefficient is, which is 6. And now, the next thing you have to do right at this point is to take a look at these fractions and simplify them. This actually becomes 3 seconds, and this one becomes, so it's x minus 4 thirds. Simplify these fractions as much as possible. Then the denominator goes in front of the x, and if the denominator is 1, you put a 1 in front of the x, or you just leave it blank because that means 1. So here we would have the 2 slides down in front of the x, and we have a positive 3. Here, this 3 slides in front of the x, and we drop down the minus 4. And if you were to FOIL this back together, multiply it back together, you get 6x squared. And you get 9x and negative 8x, which is 1x. And here you get 3 times negative 4, which is negative 12. So it works out. Solve by factoring. Now, when we solve equations, we want them to be set equal to, at least with the factoring method and several others, we want them to be set equal to 0. So I'm going to set the right side equal to 0 by adding the opposite of each of them, so that these things cancel out. We get 0. And now on the right side, or the left side, excuse me, we have 6x squared minus 13x minus 5. So we try to factor this thing, looking for numbers that multiply to negative 30 and add to negative 13. And again, make a list of your factors if you're stuck on how to do this. A lot of people think 3 and 10 are the right combo, but it's not. It's actually negative 15 and positive 2. And because when I was playing with the 3 and the 10, I'm like, I can't make that work. Maybe look at other ways, and because I made my lists, got a little creative and saw that 2 and 15 work, or 2 and negative 15. So we're going to write x minus 15 times x plus 2, because it's a positive 2, but we are going to divide them by our coefficient of a, which is 6, and then we simplify those fractions. So it's x minus, let's see, that simplifies to 5 seconds, and this simplifies to 1/3, and then slide the denominator in front of the x in your factored form. So we get 2x minus 5. Bring the minus 5, bring the numerator and the sign in front of it down. Slide the 3 in front of the x, bring down the numerator and the sign in front of it. There, oops, is not our final answer yet. So that's factored form, but remember this was an equation. I kind of did a poor job of bringing down that equals 0 every time. So now we take these factors and we set them each equal to 0. So 2x minus 5 equals 0, 3x plus 1 equals 0, and we're going to get 2/5 or 5 seconds, excuse me. X equals 5 seconds. And then here, subtract 1 and divide by 3, you'll get negative 1/3. There are the solutions to that quadratic equation. Simplify and keep in mind your perfect squares. So here we look for the biggest perfect square that goes into 48, or is a factor of 48. I believe 16 times 3 is 48. So the square root is 16. That's why we use the perfect squares, because we can actually pull out factors that are integers. Square root of 16 is 4, so 4 roots of 3 is the final answer. Here we can break this up into the square root of 3 divided by the square root of 10. But there's a rule that you never actually want the bottom value to be a radical. So we multiply the top and the bottom by that bottom value. So we get the square root of 30 on top. The square root of 10 divided by the square, or times the square root of 10 is the square root of 100, which is 10. And try to break down this or pull out a perfect square here if you can, but we cannot. Simplify, we're going to multiply the 5 to everything in the other parentheses, which is 15 and negative 10i. Multiply the negative 4i to everything in the parentheses, you get negative 12i and positive 8i squared. So here's how we simplify from here. We combine the i's together, which is negative 22i. This, remember, is a positive 8. It's a plus sign right there. But I squared is negative 1, so it's the same as 8 times negative 1, which equals negative 8. So we're going to combine that negative 8 with the positive 15, which is 7. Combine negative 8 and 15, that is 7. So the best answer is 7 minus 22i. Another simplifying rule is we can't have i's in the denominator. It's all about the denominator. No negatives there, no square root signs, no i's. So when I multiply, you're going to multiply the bottom by, if it's a single term itself. If it was a binomial, you'd multiply by the conjugate. Look that up. Hello, Google. So we get 30i plus 12i squared on top. On the bottom, you get 36i squared. Here's the beauty. On the bottom, 36i squared is the same as negative 36, because I squared is the same as negative 1. Here, this would also become negative 12i, because we have negative 12 times, we have 12 times negative 1, and we get plus 30i. This is a pretty good answer, but really we can divide everything by, at least 3, 6. Yeah, so like distribute 1/6 through, or divide everything by 6. You get negative 2 plus 5i over negative 6. I should have divided by and then like that's a good answer, but I'm going to multiply everything by a negative 1, so we don't have a negative in the bottom. So we get positive 2, negative 5i, positive 6. Oh, come on. Positive 6. There is the best answer. Let's keep rolling. What's the c value here to make this a perfect square? You're going to take the b value divided by 2, and then once you divide those, square it. So here our b value is negative 12, so we do negative 12 divided by 2, and then we square it. So that's the same as negative 6 squared, which equals 36. Let's see why we would use that, because now we can solve this thing by completing the square. I'm going to subtract 58 first, get your constant over there, because to complete the square we want the x squared term, the x term, and then we create the c term, or the constant term, by adding some magic number using the formula we just used, b divided by 2 squared, to this. Now what we add to one side, this magic number that we're going to create, we have to add to both sides. So our b value is 6. We're going to take 6 divided by 2 and then square it. So we get 3 squared, which is 9. So I'm going to add 9 to both sides. So I get, when you factor this bad boy right here, you get x plus 3 times x plus 3, which is x plus 3 squared, equals negative 49. Now you can solve this equation by square rooting. So we get x plus 3 equals square root of negative 49, which is, if we think about this, let me do this in a different color, is really the square root of 49 times the square root of negative 1. Square root of 49 is 7. Square root of negative 1 is I. Remember, when we square root, we get a positive and negative answer. So it's plus or minus 7i. And then we subtract 3. So we have now gotten x by itself. X equals negative 3 plus or minus 7i. Beautiful. Using the quadratic formula, opposite of b, so it's a positive 4, because b is a negative 4. B squared, that's negative 4 squared. Make sure you use parentheses. Minus 4 times 2 times c. Sorry, minus 4 times ac. Divided by 2 times a. Next move, simplify what's underneath the radical. Oops, that's not a highlighter. So we get 16. Here, I'll show a little work. Although we can really just punch this into the calculator. This is 16. This is negative 40. So you get 4 plus or minus the square root of negative 40 over 4. So now let's simplify the square root of 40. So that's 4 plus or minus. Let's think about the square root of 40. That's the same as the square root of 4 times the square root of 10 times the square root of negative 1. So that's 2. Square root of negative 1 is I. Square root of 10. So that replaces the square root of negative 40. So it's 4 plus or minus 2i square roots of 10 divided by 4. Now, we can't actually combine these two terms. We can't add them or we can't subtract them because they have an I and a radical. So let's take this answer. Notice that each of the terms here and the denominator are both divisible by 2, so let's multiply by 1/2 or divide everything by 2. So we get 2 plus or minus I roots of 10 over 2. There is our best answer. Using the discriminant, that is b squared minus 4ac. So b is 8, so we're squaring that. And then we're subtracting 4 times negative 2 times negative 3. So that's 64 minus 8, 24. So I think you get 40 there. Now if you get a positive number, which 40 is, you get 2 real solutions. Here's something for your note card. If you get a positive number, like 40, you get 2 real solutions. You can get a number like 0, and if you get the number like 0, that means you're going to have 1 real solution. And if you get a negative number, it means you're going to get 2 imaginary solutions. All right.